guys, we're starting a new chapter, chapter 8, which is quadratic functions. A quadratic, so start copying these notes down. This is on page 315 of your book. And the quadratic function, the parent function is y equals x squared. It's the simplest way you can write a quadratic function. And the quadratic function is a polynomial of degree 2. Degree 2, the highest degree is 2. Degree 1 would be linear. So we talked a lot about linear in the first semester. Now we're going to concentrate the rest of this year, which is not much left, is going to be quadratic functions only. How to graph them, some story problems, how we use them in the real world and stuff that will be coming later. Right now we're going to talk about the different parts of quadratic functions and how to graph them. So f of x equals x squared is the parent function. Again, the simplest way you can write a quadratic function. The name of the graph you get is a U-shaped graph called a parabola. That's the name of the graph of the quadratic function. It's always going to be a parabola. It's always going to be U-shaped like this. Sometimes it'll be opening upwards. Sometimes it'll be opening downwards. Again, the graph, for example, 1 of your book on page 315 is going to be graphing the parent function f of x equals x squared. To graph it, we can make a table of values. In the table of values, remember you choose your own x values. Then f of x equals x squared. These are your y values, your outputs. This is the input, that's the output. We choose our own x values when we create a table. So -2, -1, 0, 1, 2 are good numbers to choose most of the time. So what we do is to find the corresponding y values or f of x values that go with these x values, we just plug them into the function. In this case, the function is simply x squared. So whatever x is, we're going to square it. So -2 squared, remember -2, whenever you replace x with a number, you got to put it in parentheses. -2 squared in parentheses is +4, not -2, be careful. So again, for x squared, again, we just replace x with -2, -1, 0, 1, 2. We did it here. We square each of these numbers, and we get +4, +1, 0, 1, 4. So this is the corresponding points you get when you plug these in. -2, +4, -1, 1, 0, 0, the origin, 1, 1, and 2, 4. So then we're going to talk about the different parts of this graph. What the vertex is, the parabola, what a parabola is, what it opens up or down. And then the axis of symmetry is a line of, sometimes called a line of symmetry, or LOS, is an imaginary line that cuts the parabola into two equal parts, two mirror images of each other. So let's go ahead and graph this and see what we get. So -2, 4, -2, 4. That's the first point. -1, 1, 0, 0, 1, 1, and then finally 2, 4. Okay, if I try to line this up with a protractor or a straight edge, it's not going to work. These 3 points, this is not a straight line. Remember, this absolute value function was a V. It was 2 straight lines. This is not 2 straight lines. If you notice, I'm going to try to line up these 3 points, and I can't. I can't line them up because it's not a straight line. This is a U-shaped curve. They're curvy. So we're just going to, by hand, line these up and know that it goes up forever in both directions. This is the parent function. This is the graph of the parent function of a parabola. The vertex is always the lowest or the highest point on the graph. So that's what the vertex is, the lowest or the highest point on the graph. In this case, it's the lowest point on the graph. We call it a minimum point. Again, this is the vertex. It's where the two sides of this parabola meet. Either at the bottom, if the parabola is opening downwards, they would meet at the top, it would be the maximum point. In this case, it's the minimum point. Again, the name of this graph is called a parabola. It either opens up or down. This one's opening upwards. Since x squared is positive, if it was -x squared, it would open downwards. That's what makes it open up or down, whether it's positive or negative, whether the coefficient of x squared is positive or negative. If it's positive, it opens up. If it's negative, it opens downwards. We'll talk more about that later. Okay, so what I want you to do now is do the try it. Example 1, try it, page 168 of your workbook this time, and then see how that goes. I'm going to continue with example 2 in the same section. Example 2, let me make sure I line this up correctly so you see everything. I think that's good. Yeah, that's good. Okay, So example 2 is, how does A affect the graph of f of x equals ax squared? A would be the number in front of x squared if there is one. In the previous, in the parent function, there was nothing there, so A was 1. Again, it was positive 1, it went upwards. So let's talk about A. If A is not 1, what happens? Well, I graphed 3 graphs here. The black one that is not highlighted is f of x equals x squared. That's the parent function. If I graphed it, it would look something like this. If I graph f of x equals 2x squared, if A is positive 2, if A is bigger than 1, look what happened to the graph. It kind of got stretched or got more narrow. You notice? The graph of 2x squared is more narrow than x squared. So the bigger A gets, the more narrow the parabola gets. Let's look at what happens when it's f of x equals 1/2 x squared or 0.5 x squared. When the number A gets smaller, look what happens to the graph. This is the yellow one right here. Oh, look at that, it got bigger. Isn't that crazy? So A affects how wide the graph is. The bigger A is, the more narrow the graph is. The smaller A is, the more wide the graph is. Again, I wrote it down here. I want you to copy all this down. The larger the absolute value of A, negatives have nothing to do with it. If it was negative 2x squared, it would still be the same width. But instead of opening upwards, it would open downwards. The negative only affects whether it opens up or down. So again, the bigger the number is, positive or negative, the more narrow the graph is. The smaller the number is in front of A, x squared, which is A, called A, the wider the graph is, whether it's positive or negative, doesn't matter. So that's why we say the absolute value of A. The larger the absolute value of A, the more narrow the graph is. The smaller the absolute value of A, the wider the graph is. Okay, so that's what always happens with parabolas. How does the sign of A affect the graph? We just talked about that. The sign of A is either positive or negative. So I just graphed both graphs, f of x equals x squared in black, and in red I graphed f of x equals negative x squared. So A in this top one is positive 1. Here A is negative 1. What happens when A is negative? It's the same width, because they're both 1 and negative 1. The only difference is the positive 1 opens upwards, the negative 1 opens downwards. Again, the negative A value makes the graph open downwards. So here I wrote down some more notes I want you to copy. If A is greater than 0, which is positive, it opens upwards. The parabola opens upwards, like that. If A is less than 0, which is negative, it opens downwards, just like this. Okay, so what I want you to do now is to try example 2 on page 168 of your workbook and see how that goes. Okay, make sure you're copying all these notes down. We're going to continue with example 3. We got example 3 and then we got example 5. We're skipping example 4 in this section. Okay, let me make sure I have it lined up right. Make sure you copy these notes down. You might want to pause it if there's too much writing there. Let's make sure it's all lined up. Okay, looks pretty good. Okay, looks pretty good. Okay, example 3 is, now we're actually starting to graph different kinds of parabolas, different kinds of quadratic functions. Over what interval? Now we're going to talk about intervals, the x intervals, like from a certain number to a certain number. And over what interval is f of x equals 4x squared increasing? Over what interval is it decreasing? Here's how we would do something like this. First of all, we'll make a table of values. We're going to go from -2 to 2 like normal. We're going to plug it into the function rule, all the x's into x squared. So we're going to replace x squared with the x with -2, -1, 0, and 2. Remember, we choose our own x values when we make a table. So it's 4 times x squared. And remember, we have to think about order of operation here. So I'm going to put -2 in here, -1. These are the x values. Replace x with the x values that we chose. -2, -1, 0, and 2. Now, order of operation, we don't multiply 4 times -2 first, then square it. We had to square first. Exponents, please excuse my dear Aunt Sally. Remember PEMDAS? We have to do exponents first, then multiply. Be careful. -2 squared, remember, is positive 4. 4 times 4 is 16. So the y value is 16. The x value is -2. The output is 16. Let's do this one, order of operation. -1 squared is positive 1. Be careful. This is where most people make mistakes. -1 squared is positive 1. 1 times 4 is 4, order of operation. 0 squared is 0. 0 times 4 is 0. That stays at 0. 1 squared is 1. 1 times 4 is 4. 2 squared is 4. 4 times 4 is 16. I hope you see a pattern of the graph decreasing to 0, then increasing. We're going to talk about increasing and decreasing soon in example 5 for sure. Or here, we're doing it now, example 3. So here's what's going on here. So it's asking, when is it increasing? When is this function? Over what intervals is the function and increasing? Over what interval is it decreasing? It's asking for which x values. The interval is for which x values is this function increasing? For which x values are the outputs of the function decreasing? So we're going to look over here. From here to here, 16, 4, 0. That's decreasing. The numbers are decreasing. Okay? Over what intervals is it decreasing? Over what intervals is it increasing? So it's decreasing in the negative sense, right? -2, -1, 0. It's decreasing. The outputs are decreasing. They're getting smaller. Then when the x's are positive, greater than 0, 1, 2, 3, so on and so forth, what's happening? You go from 0, let me use a highlighter, 0 to 4 to 16, it's increasing. You notice that? So this is what they're talking about. Over what intervals is it decreasing? What intervals is it increasing? It looks like everything from 0 and up, it's decreasing. So how would you write that? 0 and to the negative sections, it's decreasing. These are all numbers that are less than 0. It's decreasing for all numbers less than 0. So that's the next second one right here. When is it increasing? Well, starting at 0 and on. So at 0 and on, it's increasing. The values of y or f of x are increasing. So it's increasing when x is greater than 0. So let's go ahead and write that down here. F of x equals 4x squared is increasing over the interval x greater than 0. And when x is greater than 0, 0, 1, 2, 3, 4, 5, 6, the outputs, the function is increasing 0, 4, 16, and so on. When f of x equals 4x squared is decreasing, over what interval is it decreasing? It's going to be for all the values of x that are less than 0. 0, -1, -2, -3, -4. If you notice that anything less than 0, the outputs are decreasing from 16 to 4 to 0. So it's decreasing for x's that are less than 0. It's increasing for x's that are greater than 0. That's how you do increasing or decreasing. Go ahead and do the try it, example 3, page 168 of your workbook. Okay? Okay, now I'm going to keep rolling along. We're going to skip example 4. We're going to go right to example 5. Now we're going to do average rate of change. Remember, we've done this before in Agile Mind, and we're doing it again here in this book. So make sure you copy all these notes down. If you have to pause, go ahead and pause. Example 5, page 318 of your book. Compare rates of change. Remember, rate of change is slope. y2 minus y1 over x2 minus x1. In this case, we got to compare the slope given 2 points because it's not a straight line. And then the question is, find the average rate of change for these two functions. F of x is 0.75x squared. G of x is 1.5x squared from this interval, from 2 to 4, from all x's between 2 and 4. So basically, we're just going to choose x equals 2 and x equals 4. We're going to find the value. We're going to graph. First of all, step 1, we're going to graph it. Let's graph it and see how these two functions compare to each other first. So I did that on a separate graph paper. It's a C graph. I'm going to put that up right now. You might want to graph. You're probably going to want to copy these notes down also. So the function in blue is f of x equals 0.75x squared. G of x equals 1.5x squared is the red graph, the red parabola. What I did was, you can make a table of values, -2, -1, 0, 1, 2. But in this case, we went to 4 to -4. So you can pick whatever x values you want. We needed to go from 2 to 4, so I picked 2 and 4 for sure. So what I did in step 1 was graph it. I graphed them both. You can see that the 0.75x squared is wider than the 1.5x squared because 1.5 is bigger. Remember, the bigger the coefficient a is of x squared, the more narrow the graph is. So that makes sense. when you plug 2 into, let's do the f of g of x first, the red function. G of x equals 1.5x squared from x's between 2 and 4. So all we got to do is pick 2 and 4, plug them into the function, input them into the function. G of 2 means replace x with 2. So 1.5 times 2 squared. Remember, order of operation, 2 squared is 4. 4 times 1.5 is 6. Then plug 4 in. It's all simple as that. You don't really have to even graph them. You can just do this. You plug 4 into x, you get 1.5 times 4 squared. 4 squared is 16. 16 times 1.5 is 24. So these are the 2 points you get. For g of x, you get these 2 points. X was 2, f of x is, g of x is 6. The other point you get was x is 4, and then we plugged it in, we got 24. These are the 2 points. Can you find the slope of these 2 points? Yeah. Remember? y2 minus y1 over x2 minus x1. That's how you find slope. We're going to do that later in step 3. This is step 2. Step 1, graph it. Step 2, plug them in. Plug those numbers in that they give you from the interval, the endpoints of the interval. Let's do f of x equals 0.75x squared. Same thing, from 2 to 4. So plug in 2, plug in 4 into x, and then do the math. 0.75 times 2 squared. 2 squared is 4. 4 times 0.75 is 3. Order of operation. Do the square first, then multiply. 0.75 times 4 squared. 4 squared is 16. 16 times 0.75 is 12. So we get these 2 points for g of x. The first point is 2 comma 3. And the second point, making sure everything's good. The second point is 4 comma 12. And to find the slope of these, the rate of change or slope here, you simply do y2 minus y1 over x2 minus x1 like we've been doing all year. So step 1, you can graph it, but you really don't even have to graph it. Step 2 is the main one, where you just plug the endpoints of the interval they give you in for x into that function, and the answer you get will be the y value. X value, y value, x value, y value. Same thing with f of x. Plug in 2 and 4 into x, and you get an output for each one, x value, y value. You end up with 2 points, and then when you got 2 points, you can find the rate of change. Let's go back to example 5 here. So here's step 3. After we did step 2, I did step 2 on the other page. This is what I got, right? And they end up being 2 points. 2, 6, 4, 24 for g. For f, it's 2, 3, 4, 12. Now to find the slope, just find the slope of both, well, to find the rate of change, to compare the rate of change, you just find the slope of both of these points. Again, y2 minus y1, y2 minus y1 over x2 minus x1 equals 9. The slope for f of x, y2 minus y1, 12 minus 3 over 4 minus 2, x2 minus x1. Do the math, you get 9 over 2, 4.5. Now compare the slopes. Which one had a steeper? Which one was steeper? Well, g of x was steeper because it has a slope of 9. The sides of g of x in the U-shaped curve were steeper because it has a greater slope. And then the f of x is going to be less steep because it has a slope of 4.5. And it makes sense because f of x has a smaller number, coefficient 0.75, so the graph was wider. If the graph is wider, the slope is going to be smaller. If the graph is more narrow, the slopes of both ends are going to be higher, greater slope. So what I wrote here was the slope rate of change, slope or rate of change mean the same thing, of g is greater than f because the sides of g were more narrow, were pointing more straight up. What I want you to do now is try example 5, page 169 of your workbook, and we will be done. I will be giving you homework soon, probably of course, on Easy Bridge, obviously. And that's it. Thank you, guys. That's it for 8-1. We'll continue this another time.